Hey guys, I figured that now would be a great day, as good a day as any, to solve this here geometry problem. We've got something that, hang on, let me get rid of this cursor here, which is sort of killing my buzz. Nobody likes a blinking cursor, muddying up everything. Okay. In the figure on the left, point D is the center of the circle. That's this point right here. Line segments AB and BC are tangent to the circle at points A and C, and the segments intersect at point B. Okay, so we have a picture, but also a written description. When the picture makes it clear what's happening, you don't necessarily need to read the description. You can just look at the picture and say, okay, what is going on in this picture? And then skip right down to this. If the circumference of the circle is 64, what is the length of major arc AC? Well, first of all, let's figure out what we mean by a major arc. There's really two things here. We need to worry about the major arc and also how to find a portion, only a portion of the circle's circumference. It's also got to depend somehow on the information that's given to us from outside of the major arc itself. So what is a major arc? What does it mean that we're talking about the major arc AC? Well, there are two types of arcs in circles. There are minor arcs and major arcs. Now, this is not music class. The difference between them is not whether they're sad or happy. The difference between them is whether you're talking about a small portion of the circle or a large portion of the circle. In red now, I'm going to put the minor arc. This right here is the minor arc AC. Now, ordinarily, if you don't specify which one you're talking about, you automatically mean the minor arc. So if I just said arc AC, you would actually assume that I was talking about the minor arc from A to C because it's the most efficient way to get from one place to the other. But the major arc is the one that goes around the circle the inefficient way, the long way. This right here in green is the major arc. So we're looking for the length of that thing right there. To figure out what portion of the circle that is, we have to figure out what the angle is here in the center of the circle, because it's like a pizza. When you cut it, the angle there at D determines how much of the circle is occupied by the minor arc, and the leftovers will be the major arc. So here's what we're going to do. We're going to find the circumference of the circle. And this is actually super easy for us because it's already found. Determine the portion, and then calculate that portion of the circumference. Okay, so easy enough, but everything is going to depend also on knowing the relationship between these segments. Whenever you have a tangent that intersects with a radius, you should be able to know that that makes a 90-degree angle. If you don't remember anything else from this video, remember that a tangent and a radius always form a 90-degree angle. So this right here is 90 degrees. There's another place where this happens in the figure, and it's down here at point C. This also is 90 degrees. So the reason this is valuable is that now we know not one angle, which is what we knew before, but now we know three angles. Think of this as a four-sided shape, A, B, C, D. Here it is from A to B, from B to C, from C to D, and then back from D to A. In a four-sided shape, you always know the total of the four angles. It has to be 360 degrees. If you have trouble remembering that, just remember a rectangle has four right angles that always add up to 360. And that's true of all four-sided shapes. So you've got 45 plus 90 plus 90, that's this, this, and this. And then if we let this be x, adding x has to give us 360 degrees. Well, this is not a hard equation to solve. 90 and 90 is 180. And then the 45 on that is 225 plus x equals 360. So if you subtract 225 from both sides, we're going to get that, well, 100 minus 20 is 140, minus 5 is 135 degrees. So this angle right here is 135 degrees. That means that it is 135 degrees worth of the 360 degrees of the circle. So I'm going to break the rules a little bit that I mentioned earlier and go directly for this. If that's 135 degrees, then what portion is outside of that? Stop for a second and see if you can get it. Hint, it's related to this problem we just did. The difference between 135 and 360 must be 225. So this is 225 degrees worth of the circle. Now we have the solution because it's 225 360ths of the circle. And then we're going to be multiplying that by the circumference, which is already known to be 64. Now, if you have a calculator, you could get this in a snap, but let's assume you don't because this is gettable without a calculator. So let's do it without one. 225 over 360, that can be reduced by 5s, which will give you 45 over 72 times 64. And then by 3s again, 15 over 24, and that times 64. Now let's reduce these two. And let's see, that can reduce by 8s. So that'll turn into 15 over 3 times 8. 15 over 3 is 5. Times 8 is 40. So what is the length of major arc AC? It's got to be 40. And there you have it.